Hello everyone. In today's video we are going to see what are the security mechanisms. So according to X800, the security mechanisms are divided into into those implemented into a specific protocol layer, and those are not specific to any protocol layer. So we have protocol layers, right? We have a OSI model which has 7 layers. So these security models are like those security measures or those security mechanisms are applied to only some specific layer. We have 7 layers in OSI model. Okay. So this is I'm just telling the names of the layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So all these are 7 layers of the OSI models. So these security mechanisms are applied to only some specific layers based on the type of security mechanism. And now let's see some security mechanisms. These are specific ones. First one is encipherment. So this means the process of applying mathematical algorithms for converting data into some form that is not intelligible. That means whenever the data is being transmitted from the sender to receiver, we will apply some algorithms. So why do we apply some algorithm? Because if we send the message as it is in the channel, I mean whatever we are sending, then anyone who can access to that channel will understand the message. Okay, that means third party. So if not like that, if you are using any specific algorithm, so using that algorithm, the algorithm will change the data into some format. So there are different types of algorithms like RSA algorithm, SHA algorithm. In SHA also we have SHA-1, SHA-256, 512. So we have many different algorithms like this. So this algorithm will not be disclosed to all the people. Okay, this will be hidden secret, because if they know algorithm, if they encrypt the data, then they also can be decrypt the data. That is why the algorithms will not be known to the other people. So what this encipherment will do is they will use the algorithms which will convert the data into form that is not intelligible, means that is not human readable, which humans cannot be read. See, for example, if you are sending hello message and they used some algorithm and they have changed this to some O V A Z B. Okay, this is not at all a data. Okay, this is not understand by anyone. But if they know that okay, RSA algorithm is used, for example, let's say we have used RSA, this is not the actual result. Okay, I'm just telling for example. So if the RSA algorithm is, if this is known to the hackers or anyone, what they will do is they will decrypt the data, because in the algorithms what we will have is that we will have some format, or for example in this RSA algorithm, A means it should take the letter E, B means it should take the letter some F. So this will be a standard format. Okay, now what the decryptors or attackers will do, they'll just decrypt. Okay, if it is O, so they'll go reverse. For H it is O, you guess, so they'll take H. For V it is E, so E V. So okay, for it is V here, so they'll change to E. So that is how they will find the original data. That is why we should not tell our algorithms. So this is just a basic just to make sure that understand, but real algorithms will not be this much easy. We will have different kind of formats also in that. So this is what encipherment means. And digital signature, this is appended to the data, original data, or cryptographic transformation applied to any data, allowing to prove that the original sender is the actual sender or the receiver is the actual receiver. I'll explain this here. Okay, so that means we have data, right? The data is hello. Now they will append the digital signature. Signature means that's not actually sign. Since it is being transmitted digitally, virtually, they will just use this digital signature. Signature is like verification, for verification. So at the end they will append some XET. This is their signature. Okay, now they will modify this data just like this. For example, OVAZBXET. Now what the hacker will understand if this kind of message if he receive. So even though the hacker receives, they can't understand the data. So that is what the encipherment in digital signature power is. So what will happen, what receiver side will happen is, whenever the data is received, first it will check for the signature. This signature will be known to only sender and receiver only. That means this, just like the algorithm, the signature also will not be known to everyone. So they will verify the signature. That means, for example, here last three words are signature, sorry, three letters. Okay, so this is sender sending the data. Now receiver also received the same data only, OVAZBXET. So they will have priorly what how many letters have signature and what is the actual signature. So they will verify this XET. Okay, this is matched. And now let's this is encrypted form, right? Let's decrypt, and then they will check for the received data and the sender sended data, and then that message will be delivered to the receiver. This is what happens completely behind the scene. Okay, this all things will happen within seconds in the network only. So this is what digital signature. We will learn more about this digital signature and encipherment in the future. Okay, using example and using the perfect algorithm and how that happens completely, then you will get a clear understanding. This is just for the concept understanding how it will happen and all. And the next one is access control. So access control means there will be many techniques used for access permission to the system resources. That means they will have a certain level of access. That means only this kind of users will have access to this particular message or this particular data. Those permissions will be all managed in this access control layer or access control service. Next, data integrity. So many mechanisms are used to make sure that the data is integrity. That means whatever the sender is sending the data, that is the only data receiving by the receiver. There will not be any modifications in between. And next one is traffic padding. This is also one of the interesting concept, just like digital signature and encipherment. So traffic padding is insertion of the bits into gaps. So what happens in this is, just like the sender and here receiver, we are sending hello. Okay, and this hello we have taken OVAZB, right? Yeah, let's take this. Okay, now what you will do is padding means insertion of some bits in between the original data. So and what how and what will happen is, if the algorithm is having that after every 3 letters you have to insert one bit, then you will insert here some like a. Okay, this again insertion will happen depending upon the their algorithm and depending upon their in company information. Okay, and after 3 letters I have to insert one bit. Now OVAZB. So even if the attacker or the third party get access to this, they will get the OVAZB, but they will not know that they are using padding technique. So what they will do is, they'll try to somehow find an algorithm to decrypt and then they will try to analyze what the actual data is. So this traffic padding also will make sure that the data will not be hacked or it will not be posed to danger in between the transmission. So this is what traffic padding means, and this traffic padding will not only using these letters and all this encipherment, digital signature and traffic padding, they will be done using binary values as well, 0 and 1. Okay, that's all. Thank you.